here's where we're starting today. This is our first example for today. Does it look familiar? Oh yeah, we did this yesterday, right? Remember this? Remember this? It was a whole page of work that we did yesterday, right? So we're going to do the same example today for a reason. You'll see why in a second. How did we do this example yesterday? Substitution. Okay. Do you remember what it's called that we're going to do today? Elimination, right? When we talked about graphing yesterday, did we talk about graphing because we're going to graph stuff?
No.
So why did we talk about graphing?
So we know how order triple.
So you know how to write the answer. It's an order triple. Excellent. Okay. Good job. So we're going to solve this system by elimination. When we talked about elimination when it was just two variables, when it looked like that, we just eliminated a variable once, right? We eliminated one variable which solved for a variable for us, right? If we eliminate a variable once here, I still have two variables, right? So what I'm going to end up doing is eliminating the same variable twice. So if you'll give me some patience, I'll show you why we're going to do that. And I hope it'll make sense. Does that make sense? Okay. Before we start, though, what I want to do first is decide which variable would be the easiest to eliminate in this particular problem. Okay? So let's make sure you understand why. Because I agree with you. I agree that x is going to be the easiest, but I want to make sure you understand why. Is that fair?
Sure.
Okay. So if we're looking at the x's, and I'm telling you right now that we have to eliminate it twice, if I just look at the top two, are those two going to be easy to eliminate? Yeah, because I just have to multiply the top one by what? -3, right? Because then I'll have a -3 and a +3, right? So if I have to eliminate again, which two would I use this time? Top and bottom, right? And what would I have to do to eliminate the x this time?
Divide by 2.
Multiply the top by
Oh.
-2, right? Because remember, they have to be the same number but opposite signs, right? Okay. So in this case, I'm multiplying the top by -3, combining, and then multiplying the top by 2, and then, -2, and then combining, right? Okay. Let's look at the y's, though. Look, I already have some opposite signs going on here, so that might be nice, right? Here also.
Right.
What would I have to make these two y's if I was going to eliminate those two y's? I would make them 6, right? So if I was going to make the y's 6, what would I have to multiply the top equation by? A 2, right? And what would I have to multiply this middle equation by? A 3. They're already opposite signs, so I just multiply by 2 and multiply by 3. That's super easy, isn't it?
Right.
Okay. Could I multiply these two next? What would I have to make these two to make those go away? 10? 10, okay. So that means I'd have to multiply this one by 5 and this one by 2, because again, they're already opposite signs. So between x and y, which one is easier?
Probably
Definitely x, right? Okay. What about z's? Would this be pretty easy to?
No.
What about if I use the top and the bottom?
Well, you can do 12.
Or even I could do 6, right? So I just have to multiply the bottom one by -3, right? I wouldn't even have to multiply the top one by anything if I want to make it 6, right? Okay. Which other two would I combine to try to eliminate the z again? Probably the middle two, right? So I would have to make that what? 10. Okay. And again, they're already opposite signs, so that's nice. But even through all that, which variable was the easiest? The x, right? So do you understand why it's the easiest?
Yes.
If these were your two options, and I said you weren't allowed to eliminate the x, I'm not going to do that, but I'm just saying, suppose I did. Which one would you choose, y's or z's?
Probably Y's.
You would choose y's. Somebody else would choose these, though. Is that okay?
Yes.
Is it okay that some people
Still
choose to
get the
eliminate
same
one
answer.
variable and yeah, because you'll still get the same answer, right? Okay. If you do all the steps right, of course, right? Okay. So you guys said we should eliminate x's, so let's do that. Okay. So if we're going to eliminate the x's the first time, which two do you want to eliminate first? Top and middle or top and bottom? Top and bottom, okay. So if I'm going to eliminate top and bottom, or if I'm going to use top and bottom, what am I trying to make x's become? 2, right? 2 and -2. So I'm going to have to multiply this equation by what? -2. Are you okay with that? So are you okay if I write it right down here? negative 2x plus 6y minus 12z equals negative 42. Now, I'll tell you right now, a lot of people remember to multiply that. And a lot of people remember to multiply that. And a lot of people remember to multiply that, and they get here and they write 21. Be careful, okay? That's why I purposely put the parentheses around everything. So you remember we're multiplying everything by the negative 2. Does that make sense? Okay? Now, I'm just going to rewrite this one right here so I have it a little closer. Okay? All I'm doing right now is rewriting that third equation. So now, when I combine them, what am I hoping happens? I'm hoping the x's go to 0, right? Do they? Negative 2x and positive 2x? Yes, it does. 6y and 5y? You get y. Negative 12z and 2z? Negative 10, right? Negative 10z. And then what? Yep. Okay so far? Now, I have one equation with y and z. If I have one equation with y and z, what do I need? Another equation with y and z. Okay? I don't want to try to eliminate z's now, because since I already eliminated x's once, I want to eliminate x's again, because if I eliminate x's again, it's going to give me another equation with y and z. Does that make sense? Okay, so we already used top and bottom, so I can't use top and bottom again. What should I use this time? Top and middle, okay. If I'm using top and middle, what am I trying to make the x's go to? 3 and negative 3. Perfect. So if I'm making this top one go to negative 3, what do I have to multiply it by? Negative 3. Okay. I'm going to write it right over here. You okay with that? Negative 3x plus 9y minus 18z equals negative 63. And then I'm just going to rewrite that middle equation right here so it's close. Now what do I do?
The x's cancel each other out.
Yep, I'm combining, right? So negative 3x and 3x, 0. That was my goal, to get the x's to eliminate. 11y. Negative 23z equals? Very good. Negative 93. So now I have two equations with y and z. Isn't that nice? Now what do I do? If I combine them, will anything eliminate?
No.
So I want to combine them in such a way that
They will eliminate.
one will eliminate,
Wait,
right?
So is this the part where you would say that, like what we just did?
Yeah, I kind of start over, don't I?
Multiply it,
But with these two, what do you want to multiply by?
Negative 11.
So multiply this one by negative 11. Is everybody okay with that? Are you okay if I write it right over here? Okay, so negative 11y plus 110z equals 528. I did that in my head. Can I show you how to do it in your head? Yes? Okay. So it was 48 times 11. This is a trick that works for 11s. Okay? You know other tricks, but this is a trick that works for 11. Outside number here, outside number here. The middle number is these two added together. Except it's 12. So I carry my 1, and that becomes 5. It is. Okay? Now you know a trick. Okay? All right, back to here, back to here, back to the show, commercial break over. Now if I'm combining these two, what happens?
They cancel out.
Yeah, y goes away, right? It goes to 0. What do I have left here?
97. Oh.
Close. Yeah, 87 and 435. So to solve for z, I divide both sides by 87, and z equals 5.
Okay, so now you have to do something with the middle equation.
Not necessarily. Wait, what do you mean by middle equation?
Well, we didn't do anything with the second one.
We did. Yeah, remember we multiplied the top of my -3 and added it to the second one right here.
So now we know the last number that's going to be in the ordered triple.
We do. We know the last number in the order triple. How do I find the other two?
Oh my God.
I know z, and that's great, but what do I do with it?
Plug it in.
Where? Where do you want to plug it in?
Right here.
How about right here?
Yeah, how about that one?
Why would I choose this one?
I don't know.
If I plug z in, what am I going to know?
You're going to know why.
I'm going to know y. Okay?
And then you plug y.
So y, let's see, y minus 10 times 5 equals -48. So y minus 50 equals -48. And if I add 50 to both sides, what does y equal?
2.
Very good.
Oh, you did that so fast.
And now I know y and z. So now I'm done, right?
No, you put it.
Oh, I gotta find x. Dang x. Where do I want to go to find x?
The original 3.
Oh, original 3, doesn't matter which one?
No.
Which one would you choose then if it doesn't matter?
Top.
Why would you choose the top?
Because the X is nice.
Yeah, x is already by itself, right? So x minus 3 times 2 plus 6 times 5 equals 21. So x minus 6 plus 30, very good, equals 21. So -6 and 30 is
Oh, it felt like
24. Yeah, not even like 24, it's actually 24. So if I subtract 24 from both sides, very good. X equals -3.
Now we know all three.
Now we know all three, so we should write it, right? We should write our answer in the correct way. What is it? -3, 2, 5. Is it right?
So we can check.
We should, right? -3 minus 6, so -9. -9 plus 30, is that 21? Does 21 equal 21? Yeah. -9 plus 4, -5, minus 25. Is -30 equal -30? Yes. -6 minus 10, -16, right? Plus 10, -6. Does -6 equal -6? Yeah. So we know that's the right answer. Okay? Now, I'm going to zoom out just for a second because I want you to see something. This is our page for today. I know some of the work goes away, but you see it's right here, right? And then this is the page from yesterday.
It's still a lot, but it's a lot better.
It's still a substantial amount, right? But is it the whole entire page? And I even have stuff on the side, right? It's pretty compact now, isn't it? Okay. For some people, it is. Now, some people love substitution and they want to do substitution all the time, and that's totally fine. Some people like elimination. Okay. If you ask me which one I prefer, kind of depends on the problem. If I already have y equals set up for me, I'm going to use substitution, right? But most of the rest of the time, if I have to choose between the two, I'm going to choose elimination because I feel like it's faster. Now, here's what's interesting to me. When I did substitution the first time here, look what I got as my equation. And when I combined my middle and top equation, look what equation I got. when I combined my middle or top and bottom equation today, look what I got here. But when I substituted my middle equation to the bottom, look what I got. It's kind of cool, huh? Okay, so we're doing the same kind of math, but this is substitution and this is elimination. So do you see why some people prefer elimination?
Right.
Okay, but we got the same answer, right? Let's do another one. Now, what I told you when we started on that last one is a lot of the times we have to eliminate the same variable twice, right? Notice that I didn't say we're going to have to eliminate the same variable twice every single time. Because here is a time that I don't have to eliminate the same variable twice. Can you tell me why I might not have to eliminate the same variable twice?
Because
There's
there's not a z in the second one.
not a z in the second equation.
Can
So does it make sense that I could eliminate the z one time using the top and bottom equations
Right.
and then use the second equation to eliminate either x or y using that first thing that I got? Well, let's do that then. Are you okay with that? All right, so if we're going to eliminate the z using the top and the bottom equations, what do I need to do?
You get it the same.
I need to get them the same number opposite signs. So what number do you think I should try to get these? 2, right? Well, this one's a -2 and this is a -1.
So we have to multiply the bottom one by -2.
Multiply the bottom one by -2. That's absolutely right. Okay? So I'm going to rewrite the top one so that it's right here. And then I'm going to multiply the bottom one by -2 and write it right underneath. Are you okay with that? So positive 8x, right? Because it's a -4 and a -2. And then minus 2y, and then plus 2z, and then -24. Now my goal is to make the z's go to 0, right? Did I succeed in that goal? Is that going to go to 0? Okay, so let's combine them. X and 8x, 9x, -y and -2y, -3y. That's 0, and this is -30. Now once I get two equations that have the same two variables, they have to be the same two variables. Now I start over, right? I try to eliminate another variable. Which variable do you think we should try to eliminate here? X's or Y's?
What?
Wait. Why?
I don't think why. Is it why is smaller?
So Y is smaller,
But x is just 1.
but X is just 1, right? And tell me what you mean by that. X is just 1.
You only have to multiply it by 1.
I only have to multiply one equation by something to make it become the same thing, or opposite signs, right? These are already opposite signs and they're smaller, but these I only have to multiply by 1,
Right.
okay? So it's your choice here if you want to deal with smaller numbers or if you want to deal with only multiplying by 1. Or multiplying one equation is what I'm trying to say. What do you choose? X's or Y's? Everybody okay with X's?
Yeah.
Okay, if I multiply by, if I'm trying to eliminate X's, what am I multiplying this one by? -3, right?
Right.
So I'm going to multiply the whole equation by -3, and I'm going to write it underneath. Are you okay with that?
Right.
If I write it right over here?
So we
-9x minus 6y equals 75.
Wait.
No, we're not quite.
What's up?
I'm confused.
What part? Tell me why.
Where you got this -3 from?
So I know I have to eliminate x's. That's what you guys told me you wanted to do, is eliminate x's. So in order to make the x's the same number but opposite signs,
Oh, okay, yeah, I see what you're
does that make sense?
Yeah.
Okay, so now I need to combine these two equations. 9x and -9x is 0. Negative 3y and negative 6y equals?
105. No, it equals like
Well, 45.
45.
Pretty sure it's 45. Thank you for confirming that. Okay. To solve for y, what do I do?
Divide by negative 9.
Divide by negative 9.
Negative 5. Y equals negative 5.
Y equals negative 5.
So we found y.
We found y. Awesome. What do I do now? Where? Where would you like to plug it in? Like over here?
Put 9x.
I mean, I can, but if I plug it into one of these two, or if I plug it into like this one, what am I going to find? X, right? Isn't that exciting? So where do you want to plug it in?
The 9x minus
9x minus 3y? Okay, I'm all right with that. So 9x minus 3 times negative 5 equals negative 30. So 9x plus 15 equals negative 30.
Now we have to do minus 15.
Good.
x equals.
Which is negative 45. Good.
Then we have to divide by 9.
Good.
And
X
x
equals
equals
negative.
9.
Excellent.
Now we found it.
What do I have left to find? Yeah, what do I lack? I lack the z, right? So what do you want to do? How do you want to find the z?
Plugging the two numbers into the first.
You want to use the first? Okay, so we're going to use the first equation and plug in x and y to that. So x is negative 5 minus y, which is negative 5, minus 2z, which is equals negative 6, right? Well, isn't this going to be plus 5? Because minus a negative? Well, it's negative 5 plus 5. Isn't that 0?
Yes.
So to solve for z, I just divide by negative 2,
Which is going to be positive 3.
which is positive 3. Excellent. So all that's left to do now is two things. Write my answer. First, write my answer. So what is my answer?
Negative 5.
Negative 5. Negative 5.
3.
3.
And now you check.
Now I check.
Yeah,
Okay. All right. Negative 5 minus 5, which is 0, minus 6. Negative 6 equals negative 6. Okay. Negative 15 minus 10.
I got it.
Negative 25. Does negative 25 equal negative 25? Okay. 20 minus 5. 15 minus 3. Does 12 equal 12? Done. Okay so far? I have one more example I need to show you because it's kind of important. Just one more. Okay? One more example.
I don't know why, but I'm losing the whole page.
Will it help if I read it to you? Okay. Negative 6x minus 2y plus 2z equals negative 8. The second equation is 3x minus 2y minus 4z equals 8. And the third equation is 6x minus 2y minus 6z equals negative 18. All right. Tell me why x is the best variable to use to eliminate first.
Because there's 2
It's only
or
gonna be
6.
2 of them that are 6 and they're already opposite signs.
Right.
And?
They're all the multiple of each
Yeah, 3 and 6 for sure. The next one I could eliminate would be these two, just multiplying that by a 2, right? Now tell me why y is the best variable to eliminate first.
Because they're all the same.
So am I going to have to multiply anything at all? I'm going to have to multiply by a negative, right? I'm going to have to multiply by a negative to make one of them positive, so when I combine them it goes away, but that's really easy, isn't it? Now tell me why z is the best variable to use to eliminate first.
I'll
They're all divisible by 2, so I'd have to multiply this by 2 and add it here. Multiply this one by 3 and add it here. So do you see how all 3 of these have good options, x, y, and z? Okay, now which one should we choose?
The Y.
You want to choose y's? Okay, I'm all right with that. If we choose y's, what should we do first?
Multiple by negative 1.
Which one?
Top and bottom.
Top one by negative 1. So if I multiply the top one by negative 1, I'm going to write it right here. 6x plus 2y plus... What?
Is there a negative 6x?
It is, but I multiplied it by a negative 1.
Oh.
It's okay. So negative 6x plus 2y minus 2z equals 8. That's a negative. It's supposed to be a minus. I accidentally drew a little line. Now I'm going to rewrite the second equation. Are you okay with that? 3x minus 2y minus 4z equals 8. Now when I add these two, what do I get? 9x, 0, negative 6z equals 8 and 8,
Negative 16.
or just 16, right? They're both positive 6, or both positive 8, so it gives me positive 16. Okay. What do I need to do now? I eliminated y once.
Yeah, add 16.
Now I need to eliminate y again. Remember, we have to do it twice. Okay. Most of the time we have to do it twice. So if I'm eliminating y again, what do you want to do? You still want to multiply the top by negative 1?
No.
If I do, can I combine it with the bottom one this time?
Yes.
Yes. Okay. So if we do that, then I still get 6x plus 2y minus 2z equals 8. And that's me multiplying the top one by negative 1. This time I'm going to combine it with this bottom equation. 6x minus 2y minus 6z equals negative 18. You okay with that? So 6x and 6x is 12x. And then 2y and negative 2y,
Cancel out.
okay? And negative 2z and negative 6z,
Negative 18.
negative 8z equals negative 10. So now I have two equations with x and z. So now I need to eliminate one of those. If I'm eliminating one of those, which one would be easier? What would we make z's to eliminate them?
That's 6. Wait, what did you say? Can you say it again?
What am I going to have to make the z's to eliminate them? What's the smallest number that they both divide into? Not by, but into.
Wait, 30.
16.
16. No?
24?
Oh, yeah, 24.
Yeah,
So it's
24.
3.
Okay? So if we're eliminating z's, what am I going to have to multiply this equation right here by? And I'm trying to make the z be 24. So 4. So 36x minus 24z equals
Equals like how about like 60?
50 something like that.
64. 64. Now if I'm eliminating z's from here and I'm trying to make this 24, I have to be careful though, right? Because what has to be true about the numbers?
Has
Same but opposite, right?
So that has to be negative 3.
Yeah.
Negative 3, absolutely. So if I multiply this one by negative 3, that's going to give me negative 36x plus 24z equals 30.
Whoa, we just eliminated 2 at one time.
Do you see that?
I do.
Is that a problem?
So does that mean no solution?
Wait, it might be a
It
problem.
might be a problem,
because we
right?
have to still figure out the answer.
36x and negative 36x is what?
Zero.
And negative 24z and 24z is what?
Zero. So
Zero.
now we just have 94.
So 0 equals 94.
That's not, we can't do anything.
Does 0 equal 94?
No.
Will 0 ever equal 94?
No. Zero
Okay,
equals zero.
so here's what we're going to write as our answer then.
No. Solution.
How? By B.
No unique solution.
What do I mean by no unique solution instead of just saying no solution?
Because these questions are unique.
Do you remember that these are three planes that could intersect somehow? They could all three intersect at a line. So there could be infinite number of solutions, or these three planes could all be parallel, so they would not intersect at all, right? What we just discovered by saying 0 equals 94 is that there's not one point that they intersect at. We don't have enough information to know if they intersect at all. We know that 0 does not equal 94, so there's not a unique solution. There's not an ordered triple that we can write down. Does that make sense? Okay. Do you have any questions about solving a system with three variables using elimination?
No, ma'am.
And if you start working on your homework and you do have questions, what should you do? Yes.